Third slide. This is I'm trying to explain about today morning. There is some project on oil and gas, especially near Australia. Woodside is a company name, and there is a Pluto project. Impex, I already explained this one. Impex is also company name. The Ichis field. And Apache is also coming from Woodside. And some field development ideas and petroleum fluid characteristic. So Woodside is a company name. Discovered the Pluto site here. Discovered 10 years ago, 12 years ago. It is about 200 kilometers from the peninsula. Prof is not great. And water depth is around 700, so deep, right? The location is around here. So you can see that it is also around here. So Indonesia is here, so that there are many new places, new gas field. Potential resource, the reservoir, trillion cubic feet of gas. So it's a gas field. And potential revenue, Australian dollar, billion dollar, and job creation. And onshore gas plant is so they may use what is it? Trunk line. Trunk line is pipeline, I guess. This is Woodside company homepage. Probably they have a hard time now because of the low oil gas price. Anyway, they have many projects there. Woodside Pluto project once again. The concept, subsea well and tieback. And we will see more in Dongjin's slide that there is a wells, right, small wells. So pipe drilled many times, and this is a manifold to collect the small gases coming from different wells, and then pipeline goes into main platform, riser platform. It is only collecting pipes from different sides. Flow line is saying 11 kilometers. Subsea wells are subsea wells. Right? Tied back to an offshore platform. This is an offshore platform by two 18-inch flow lines, pipelines, 11 kilometers. There's gas and condensate to an onshore LNG plant by a 35-inch export pipeline. This is bigger pipeline to the land-based LNG processing plant site B and storage and loading facility site A. So this is coming into the storage and processing, probably delivery by something like LNG tanker to the East Asia countries, Japan and Korea. Onshore LNG plant per year is a production capacity. Right. So subsea wells, tied back, gas and condensate export pipeline. Onshore LNG gas treatment plant, LNG, LPG and condensate storage. Turning basin and shipping channel, export jetty. This is export jetty. This is jetty, we call it jetty, or the tankers. Because this is a gas and it is not difficult to loading and unloading. Especially here is a loading charges, right? So simpler than other operations. Say container cranes are very complex. Operational for 20 or 30 years because they expect the reservoir can produce a long time. This is impacts each field. I explained Tuesday. So location is more north side than Woodside, right? Impacts. More near Timor of Indonesia. 200 kilometers from the mainland. Water depth is shallower than Pluto. So this is the place, Ich's place. I don't know what is this one. And the same slide, we already see this one. Tuesday. Samsung and Daewoo got a project, and they are still struggling to deliver this project. Probably this year they deliver this. And more explanation on CPF. Design capacity, semi-submersible, the style, how do they float and move, semi-submersible, the buoyancy coming from here, and the strut is, a column is smaller, so that the buoyancy, or they can be very can be dangerous for stability. Anyways, 4-leg semi-submersible hull structure and mooring lines, altogether 28 total mooring lines. And inlet flow is coming from the seabed, control and manifolding. Riser is a pipe coming from the seabed, flow lines, and 3 production trains. In the separation system, this is about topside. Separation usually separation of water, separation of soil, the sand, there is a mud, and there is some first thing to separate, and then afterwards they separate out oil and gas or some unneeded chemicals. Right? The first thing is the physical separation of water, gas, oil, and then mud. TG, gas dehydration. So TG is over there. Gas export compression and discharge, pressure, compression 2, and condensate. Condensate is liquefaction to the FPSO. So there is another ship is coming. So this is a CPF. There is another one for FPSO. So in FPSO they also have a processing. So this is a first stage processing, simpler processing, just separation and dehydration and condensation. Accommodation of, this is personal, crew members, utilities, chemical injection, package, TG generation, MEG, and subsea hydraulic run. FPSO is coming to the Daewoo. Weather vane turret mooring. Weather vane turret mooring. I don't see turret, should be around here. Right. Weather vaning means if the turret is trying to escape from wind or wave, so that ship is rotating around turret, so that wave effect is minimized. That we call the weather vaning. Turret mooring. Mooring lines 21 volt altogether, pass swivel, and storage. The FPSO has a storage of 1 million barrel condensate treatment. So condensate is coming from CPF. They also doing some treatment and chemical process, stabilization, 3-phase of separation also again, heat exchanger to stabilize a condensate, tank capacity, and they remove mercury and flash compression, image again, regeneration, and then water treatment also again, and then shuttle tanker. They finally export the gas to the ship. This is the same one I already showed to you. See that the whole project is big. And location in Tokyo head office. It is joint venture between Total Australia and INPEX. And this one is drawing coming from INPEX. Right? And there's a date. I cannot read the date. Right, this field architecture, and you see that CPF is here, FPSO is location here. The pipelines from the seabed, it's wells and manifold and pipelines on the, and then riser collected here and then transported into FPSO. There's a configuration. In 3D shape, you see that this is another oil field coming from Woodside again, but that different location. You can find more information from website. So this is 10 wells, very small field with 2 manifolds. This is a collecting manifold, wells and manifold. And gas injection and 2 water injection wells. Dual production flow lines is doing dual production, and flexible lines means the riser is made of steel pipe, but still they are flexible. So that because of this weight of riser, because this is depth is say 700. No, this is different field. We don't know yet the depth. Anyway, if water depth is 500 or meters, the weight itself of the riser is very high, right? Only weight of riser, because it's several hundreds of meters. So that the weight, how can you manage the weight? So many times they use some buoyancy material here to make them neutral or share the weight by not only by ship but by another means. So we call this is because the length and diameter ratio is very small. It looks like very flexible wire, even though it's big. So we say that flexible. Building blocks of field development. The reservoir is the most important thing. So, what can be the size? What can be the chemical inside? Right? Economy and treatment. Can we produce? Is how far, how deep is it, or the weather condition there, and hydrocarbon, oil or gas processing. The top side is used for processing, and subsea production options. Nowadays, because the water depth is getting deeper, so that, say, if you think about 2,000 meters of depth, then pumping of the resource is very expensive operation, right? So many cases they want to process on the seabed, near the seabed. Simple treatment, say separation something, right? Water or soil can be separated out. So nowadays, as the water depth is going higher, they put more processing capacity downward. There is a trend. So they are saying subsea production or processing options is increasing. And health and safety and environment is ever increasing importance to any industry. Final investment decision, because it's a big project, big project. Hundreds of billion, several tens of billions of dollars. So it should have a big decision by consortium of investors. Plan, you should have a drawing and plan and books. And there is many new oil mega projects you can find from Wikipedia. Petroleum fluids, there are many. This is company, FMC Technology, probably from Norway, located in Norway. They are very good, specialized in seabed, on deep ocean processing. Wells and Christmas trees and manifolds and pipelines and ROV. ROV is a robot, remote controlled robot. They need to, because people cannot work here. It is too high, too deep. The pressure is too high for humans. So robot is working and installing and maintaining, repairing. So this is a famous company for this. And natural gas composition. This is a project named Pluto. We already see that it is field. We did not see that, but the other field and reservoirs. Reservoirs have different composition, gas composition. This is, I guess, is all gas reservoirs. So you need CO2, LNG, LPG. So it's a combination of them. So you need to separate out and which one is removed, which one should be collected, and how can you do that? So the processing equipment selection, how big is the size? There is a designers, as a designers you should select. This is final slide from me. This is what? Probably this is a reservoir. And typically the gas is above, oil is in the middle, and water should be down, right? And then you need to inject gas or water. Then the pressure is going up and gas is coming easier. Right? So it should be circulated because they separate out water. Right? So water can be injected again to increase pressure, to ease up the pumping system. Separation and conditioning facilities, land-based, platform-based, or floating. Platform, they are saying there's fixed platform. Footing or floating nowadays, because water depth is increasing, more goes on in floating type. In old days, it was most of them was land-based. In the middle, it was footing, jack-up style platform-based. The processing is similar. This is a separation unit. It can be land-based, it can be platform-based, it can be floating-based. Nowadays, more on floating-based. But distance can be up to 100 kilometers. Chemical distribution, commingled flow. Anyway, there is a manifold collecting, and riser is going up. Question? No. Next. No.
Okay, now let's talk about subsea production system. My name is Dongjin Kim, and thank you for listening my lecture. Before start, think about oil mining itself. What do you think? What do you have images? to me, it has a lot of dangerous factors. It's a story about super high pressure and flammable material, right? That's why oil well has a lot of control mechanism, but life always goes in wrong direction. For example, let's remind of a 2010 accident in the Gulf of Mexico. Do you remember? Deepwater Horizon explosion. At that time, British Petroleum and US government cannot lock up the oil burst area around half years. Offshore oil mining may have a bigger issue compared with onshore situation. Simple. No one is there under the sea. How can you handle and control it? Think about pressure and corrosion. You cannot even restrict the mining area. Basically, that's why undersea facility has a lot of components and focuses on safety issues. Offshore oil, now think about those panoramic vision. You are now inside the deep sea watching undersea oil production system. First, there are many cables. Similar, but we will learn each difference later. Here we have umbilical, riser, and flow lines. And then there are wellheads everywhere. And on top of each well, there are trees. Between wells, there is manifold. And actually, where is the area where you drilled to get the oil or gases? But don't underestimate the size. What we look at through computer is reduced. Watch those person beside the facility. Now you may have a real sense. Now, this is a subsea wellhead. It makes pressure containing interface of drilling site with cabin housing. You may remember the video of drilling mechanism. Do you remember those step-by-step drilling? General well has 5 rating of specification: 2,000, 3,000, 5,000, 10,000, and 50,000 psi pressure endurance. And for Korean student, 1 psi is 6.9 kilopascal. They have operating temperature range of -10 to 121 Celsius degree. On top of the wellhead, there is a tree. We called it Christmas tree because of its appearance. Does it seem like a Christmas tree? And originally, many concepts were made in the onshore oil well technology. This is an onshore oil well, onshore Christmas tree. What does it function? It's a combination of a valve, spool, and fittings. It controls the pressure on top of the wellhead. It directs, regulates, and controls the fluid flows. Sometimes it injects protection fluids against corrosion and hydrate solidifications. But this design seems no endurance under the sea. Actually, that's why we have different designs. Then what's the difference between onshore and offshore tree? There are variations. Do you see the external appearance? Which do you think is stronger? Naturally, the right one. Actually, what you see here about the offshore tree is protective structure. In undersea productions, trees and manifolds are enclosed with this protective structure. Why? Because of, for example, towed fishing gear and other several unexpected situations might be happen. So that's why in offshore tree we have those armor surrounding the real structure, like this and that. And now let's get deep into offshore trees. Basically, there are 2 types of offshore tree: vertical tree and horizontal tree. Which one do you think is vertical tree? The right one. And each stands for vertical tree. For VXT, it means vertical Xmas tree, and HXT, which is a conventional one. What do you think? VXT is a conventional one. Many characteristics of the VXT is that the bores run vertically in the tree, with the main valves oriented vertically in the main block of the tree.
Can you slow down?
All right. On the other hand, HXT has a valve located horizontally to the side. You might see there. HXT is installed on top of the wellhead before the well is completed. The well is then completed through the HXT, and the turbine hanger is hung into the HXT. Which one is better? Or what do you think? The appearance or function? VXT are more frequently used, and there is more HXT on those newer well, new built well, and VXT is easier to replace because of the tubing hanger. And now there is a so-called ISO 15926. Am I right? The pronunciation 15926. Standing for is a long Industrial Automation Systems and Integration of life cycle data for processing plant, including oil and gas production facilities. It's very long, but to summarize, this is about the data process. It develops generic data model and reference data library for plants. You can see the hierarchical classifications. You see, and ISO 15926 consists of a pipeline component and artifact data collection. Both consist of valve and Christmas tree housing data collection, and so on. This is data standard to make easy sharing and communication between plants. Why is it important to subsea plant business? Because in subsea plant engineering, there is no much trial and error process because it's too big. So when you make it, it is what you make it. You have to share plant data between other facilities to reduce the error. That's why standard is important, and we have those ISO standards. And now let's talk about the failure case. As mentioned before, there are many cases. For example, as I mentioned, disaster on Gulf of Mexico was one of them. There was a sudden increase on wellhead pressure due to the methane gas emission. And so wellhead and Christmas tree cannot endure it, which makes oil spill and make explosion on semi-submersible drilling rig, the name Deepwater Horizon. And actually, the Deepwater Horizon is a product of Hyundai. That's not their fault. Anyway, they made it. And that during that accident, 11 were dead by explosion. Here, another case of failure. Trees failed on gauge filling. It is due to well open on the wing valve caused by erosion. Also, there is a flow assurance problem on pipelines. In oil business, they call the flow assurance. There are cases of choking pipes, like oil drain in kitchen or bathroom. The water is not going well, right? It's similar. Both are blocked by solid deposit. In oil pipeline, it is consists of gas hydrate, asphalt, wax, etc., made by those reaction with environment. It is serious to oil company because of it causes a lot of financial losses. Because the flow became reduced, then you make less money, right? And now let's go to the manifolds. Manifold is a design to transfer oil from wellheads into pipeline. It combines, distribute, control, and monitor the flow. You can think of heart in the blood system. So you can predict the recommended area for manifold. What do you think? Similar with heart. Heart is in the middle of our body. So manifold is also in the middle of wells and pipelines. That makes scatter fluids or inject something into well very easily. Then, what about the pipeline? Normally, we use the terminology subsea flow lines it emphasizes on the functioning of pipelines, carrying fluid, oil, and gas from wellhead to the riser foot. But pipeline is one of the most important components of subsea plant. What do you think of the reason? It's very simple. Think about the oil burst from the pipeline, and pipeline is that transport the money, right? So this is very important, and that's why you have to design the pipeline very carefully. Here is the standard procedure of design. It's similar with the ship design, which we learned before. First, think about the transport product, or to say, think about the purpose, right? Then it will make clear way of thinking. You can get a specific requirement using that, and its correspondent codes and standards. Think about the ISO, what I mentioned before. Using that, you choose internal diameter of the pipe, and then you finish the requirement of design. Do you see? The design requirement is above, and the analysis is below. Then, you are going to decide engineering specification. For example, wall thickness and material, and there's a route on its seabed. You may have to design the route, right? And you choose how to protect the pipe, and then make prototype and do an experiment. By the way, don't forget the size of the pipeline. It is also big, very big, like this big. And after design and production, you have to install it. Actually, this is a very classical work of technology about the telegraph cable. It was firstly done in 8058. Very, old times in Atlantic Ocean. In here we have a different cable, but the scheme is basically same. Carrying a cable on a ship and laying it down on the sea. Then it will, sink to the seabed smoothly. But smoothly, do you really believe so? Of course, there is also a problem on installation. Pipeline burst is one of them. Why does it happen? Because most pipes consist of very rigid material, and it's heavy. It consists of metal, so it must be heavy. And there can be a fatigue because of material situation, right? And here is another example. It bursts like that. Before getting deeply, let's briefly take a panoramic view again. There are many lines in between equipments: umbilical, risers, and flow line. What we see before was flow line, and now I'm gonna briefly tell what is the umbilical and what is riser. Umbilical is a control and the feeding line to the apparatus. It is named after umbilical cord in your belly. You know that. And what is riser? It makes a connection to the host facility. And flow line, I mentioned it. So focus on the riser now. Again, what is riser? Riser has very important role from the very beginning, from the drilling stages. With BOP stands for blowout preventer. Most riser in the beginning stage has two sites inside, one for drilling part and the other for the cutting flow from the drill bit to the top of the BOP. It has to get rid of those cutting flow in the deep, the facing area between the drill bit and the well. So that's why you need those riser in the beginning stage of the subsea plant. And there are many types of risers. Basically, riser is very broad terminology, right? Like a cable. Here here are several examples. The production riser, drilling riser, and injection riser. But what you have to focus is complexity. You know, the structure is very complex for its purpose. And also, there is a flexible riser, which the professor mentioned shortly before. And it has an elastic layer. And this is a cross-section of real riser. It seems very big, right? I don't know which have its, I don't know which function do they have, but anyway, it's very big. Now, let's get into the flexible risers. With flexible risers, you can have a much diverse configuration, right? And obviously, it's better for controlling. If you have many options, then you may have very easy controlling, right? So here shows the 3-1: lazy wave, and steep wave, and pliant wave. Do you see? And do you see the difference on its geometry? I'm gonna briefly explain. Lazy wave is preferred to steep wave because it requires minimal subsea apparatus. However, lazy wave is prone to configuration alteration. It is hard to make, It makes a lot of changes, alteration with respect to the fluid of pipe density changes. When density changes, it makes more, the geometry change in the lazy wave compared with the steep wave. And on the other hand, steep wave can maintain its configuration with density change. So they both have their advantages. And the third one, pliant wave, is similarly steep wave, but it has those. Do you see the little green thing? It has a subsea anchor to control. In pliant wave, there is a anchor connected to the pipeline, connected to the riser. And here, tension. You can think of the those free body diagram maybe. Tension is in this case toward the anchor, not to the the riser itself. So that's the advantages. Without much tension, you may have a longer life cycle of the riser, right? And also, here, riser get support by buoyancy module. Do you see the left picture? When riser is there, you can take on those little buoyancy module to make a buoyancy force. Then you can make a control easily. And do you see the appearance of the riser? It's also big, very big. So don't underestimate the size again. If there is several advantages in every equipment, mixing will be a better idea, right? It's a very simple consequence. We have a hybrid riser. It is available to the relation, those relative motion between the floating host and the rigid metal riser with flexible jumper. Here it says flexible jumpers, right? By the way, do you see the text? It says buoyancy tank, and it's a riser anchor, what I mentioned before, and this is a flexible jumper. So, and there is a hard pipe from the surface, so-called gooseneck. Goose, in KAIST we have goose, right? Gooseneck. Now, this is the last thing. We have to protect all of them from what? Mainly corrosion, because every facilitates are made of metal. Then the corrosion is inevitable, right? So that's the end of the lecture, and thank you for listening.
I'll start today's discussion. Before start, today's class material was too hard for me before listening lectures, so I prepared two easy topics. First, it's about the homework 2. So please talk about your work about the homework 2.
The situation of the decreasing price of oil, the cost of moving by ship is relatively low. So because of that, the factor, the order of ship increases, and in the other case of increasing situation of oil price, then the demand of finding the oil and fishing from the onshore or offshore is very high. So ocean plant facilities, the order of ocean plants increase.
I think it's more complicated than simply saying that a low price of oil will lead to more order for ships. I think that the number of orders for ships depend on the state of the global economy. Because that's what decides the amount of trade between countries, not the price of oil. You could argue that the price of oil is a factor of how well the global economy is doing, but overall I think it's wrong to say that the price of oil by itself decides the number of new orders for ships.
To me, the recent change seems a quite big problem, but it does not seem the essential problem, because I think the rule of game or the system itself has not changed. To me, for example, when the airplane has invented, it might be the essential crisis to the shipbuilding company. But in this case, we have in a situation, but the situation is makes the inner conflict more actively, but not the outer conflict. So that's why I think it's not the really big crisis.
You mean this problem will be big crisis-가 아니라는
I mean, then there can be more orders for ship, right?
more, or there will be more. What do you say? Say again.
Say again. there can be more others. I don't see the negative future. I see positive future.
You have no idea. When I do this work, I found some data. The left graph shows that the development costs of ocean plant getting decreased because the development technique. So at homework sheet, the oil price of oil should be higher than 70 USD, but at this situation, more than 40 USD. So, and I investigate the oil price and the forecast data. So, if ocean plant needs more than $40 per barrel, so now the oil price of now is enough to order ocean plant, and because the oil price will getting higher, so the order of ocean plant will be increased. Go to next topic.
노동절인 오늘 경남 거제시 한성 중공업에서 크레인끼리 충돌해 구조물이 나타나면서 5명이 숨지고 18명이 중경상을 입었습니다. 현재 구조 작업이 계속되고 있다고 하는데요. 보도국 연결해 자세한 소식 들어봅니다. 백나리 기자.
네, 사고는 오늘 오후 2시 52분쯤 경남 거제시 한성 중공업에서 발생했습니다. 골리앗 크레인이 길 50에서 20m, 무게 39톤짜리 타워 크레인과 충돌한 건데요. 충돌 직후에 타워 크레인이 옮기던 구조물이 아래로 떨어지면서 건조 중인 선박을 덮친 것으로 전해졌습니다. 이 사고로 현장 작업자로 추정되는 5명이 깔려 숨진 것으로 소방당국은 파악하고 있습니다. 또 7명이 중상, 11명이 정상으로 병원 치료를 받고 있는데요. 경찰은 타워 크레인 운전자가 물건을 옮기던 중에 작업 기술로 사고가 난 것으로 보고 정확한 사고 경위를 조사하고 있습니다. 작업자들은 노동절이었지만 쉬지 못하고 작업을 하던 중에 전을 당한 것으로 추정되고 있는데요. 삼성중공업은 조선업 불황으로 경영 위기를 겪는 중에 이 같은 사고가 발생을 했습니다. 다시 한번 정리해서 전해드리겠습니다. 사고는 오늘 오후 2시 50분.
On May 1st, the accident has occurred. So the giant crane and Goliath crane crashed. So six people died and 25 people injured. So, and I know that the accident was also at March, and they didn't solve the problem enough, so this accident occurred again. So I want to talk about the most important thing in the industry area.
I think that safety is the most important concern in the industries. It's true that the aim of the company is to make money, but they must guarantee the safety of the people who are working in it, because this is the most important point.
I also agree with you. Anyway, the machines or workings are for human beings, so safety is the most important thing, and it is necessary solution.
I think safety is the most important thing for the government, because it wants to make sure that its people are safe, but the companies care more about money. They just do whatever is needed to make the regulations
regulations, but I think if there were regulations to make sure that companies made their employees safe, I'm pretty sure that it would be less safe. So making money and profits, I think, is the most important thing for companies.
Actually, I agree with safety. I thought that all you guys think safety is important, but it's not. And after that, I want to talk about this accident more deeply. I think some people say the accident is more sad because this accident occurs in the Labor Day. I think the characteristics of this industry, people cannot rest or during some day. If all people stop the working, it makes more big problem. So I feel sad for this accident, but company thinks the working is more important. So I want you to say, how can we prevent the accident?
I think to prevent accident, we have to make the workers less fatigued and less tiresome, the workers. And to make that, they have to get holiday, right, as you said, and more workers has to be hired to divide their work per person, right? It's my opinion.
To get some safety from industry about to make all of the human make the automated robot. And if there is a accident and there is no person who involved in job, we can relate the safety problem.
It is similar idea with him, but if the price of robots are too high, then we can think about some simple technologies, something like if we see the third picture situation, the crane and the gantry can be crash each other, and we can think about some sensors warning about the crash, or make the workers more careful about that. So some simple technologies can be installed in the machines for workers.
I heard that there was a sensor, but it can make error because of wind or birds. So the accident was.
I have a question, but I didn't understand if the mistake was due to the worker or to the designer. Because I cannot understand clearly why there was the accident.
I tried to find the news about it yesterday, but now investigating?
Because I think that the best way to increase the safety is to design the in a proper way. I mean, if you design well, if you look at the past accident, you can take experience from that, and so solve some problem and make more safe construction.
Also, the workers should follow the regulation. Most of the industry accidents was come from the ignorance of the rule. So they should follow the regulation.
More idea? I'll base the discussion.
노동자리 오늘
Three times 2-1 discussions, one for three all of them for discussion. First of all, the oil price and ship order. I can't remember this. Sorry, I should bring my note. You should think about the characteristic of ship. If your oil price is down, then in the car case, the passenger car can be increasing the order, say, because more people will use car more for tour or visit, but if you are thinking of trucks, cargo trucks, it cannot be the same, even though there is a oil price is down, because it is for profit, right? Truck is for profit. Passenger cars is for fun or personal use. So if oil price is down, you may expect that usage of passenger car or need of passenger car can be increased. But truck is maybe same or different, right? Because it is for profit, so there should be more need for cargo transportation. And for the ship case, most of ship is similar to truck, not for passenger cars, right? There are small passenger car like yacht or laser ships, small ships. That can be a little bit increased, but for the shipbuilding company, it should be more like a truck building company. That's one thing. A second one for the disaster in Goje shipyard or Samsung Goje shipyard. We may use similar already available technology coming from autonomous car, unmanned vehicle. They all have a technology to protect collision. Right? Vision, sensor, other automation devices. So it is easier for them because in terms of price, it is a small price for them because the crane is big and the damage is very big. So they can include such already available technology to protect such a disaster related. Third one, in general, I hope for the next discussion, I recommend to you to create a debate between. So you may choose one good topic. Today's topic is also good, and you should make them. The student can be divided into two groups, and one side should be assigned to be one side to push the other side so that they can make artificial debate. Right? So please trying to make such a debate next. All right. See you on 2 weeks time. 14th.